So far this unit, we have learned how to do mole-to-mole calculations and mass-to-mass calculations. Both of those calculations involve how much ingredients you put into a reaction and how much product you can expect to get. What we're going to do today is learn a little bit more about that product that you can expect to get. There'll be one new kind of calculation and a few vocabulary words to go along with it. First, let's do an example mass-to-mass problem. Here we have an equation. Sb2S3 plus Fe produces Sb and FeS. Here's our question. If 30 grams of Sb2S3 reacts with excess Fe, how much Sb should be produced? First, we need to balance our equation. We need 2 Sb, 3 Fes, and 3 Fe. Next, start with what you're given in the question. 30 grams of Sb2S3. We need to cancel those grams, so that means we'll need the molar mass. We'll need to add up 2 antimonies and 3 sulfurs for 339.73 grams. That's per mole. Then we need to convert moles of what we know to moles of what we want. So we look at our equation. There's 1 mole of Sb2S3 in the equation, and we're looking for how much Sb should be produced. And there's 2 moles of Sb in the equation. Then we need to convert back to grams. So 1 mole of Sb is equal to 121.76 grams. Check your sig figs here, here, and here, and your answer should be 21.5 grams. You might be wondering about this excess Fe. If you have something that's in excess, that means you have plenty of it. So since there's no numbers along with it, we don't even need to worry about that. It doesn't have anything to do with the question that we're being asked right now. Here's some of our new vocabulary. What we just calculated is actually called the theoretical yield. This is how much would be produced if our reaction ran perfectly. If we had perfect lab technique and the reaction went exactly as expected, this is the theoretical yield, when the balanced equation is used to calculate the amount of product that should be formed. Theoretically, that's how much we should get. This is also the maximum amount of product that can be produced. It's kind of like when you read a recipe and it will say sometimes on the recipe, yields 3 dozen cookies. That's about how much you should expect to be produced. All of the calculations that we've been doing, both the mole-to-mole calculations and the mass-to-mass calculations, calculate theoretical yields. What's the most product that you could get if your reaction and your lab technique are perfect? However, in real life, we know that things don't run perfectly. You might spill some. You might lose some of your product in a beaker or in a filter paper. So what you actually collect is called your actual yield. And here's our other new vocabulary term for today. The actual yield is the amount of product that actually forms when the reaction is done in a lab. So when you're all done with your lab activity and you're left with your product in a filter paper or in a beaker, how much is actually there? Usually this is going to be less than what you calculated for your theoretical yield. We tend to lose things along the way anytime you transfer a solution or a powder from one container to another. A little bit gets left behind. And so the actual yield should be less than the theoretical yield. We can take these two numbers and compare the two to get an idea for how well our reaction or our lab went. And if we do that, we get what's called a percent yield. It's kind of like finding your grade. You take the actual part that you got, divided by the maximum amount of product possible, and times by 100. And that gives you your percent yield. So, here's our final question. If you actually got 19.68 grams of antimony, what is the percent yield? The actual yield is 19.68. divide that by the theoretical yield of 21.5, times by 100, check your sig figs, you got 91.5% of what you expected. And that's not bad. For our purposes, any actual yield that comes out to be, or percent yield that comes out to be above 90%, that's pretty good.